Hello, so today we'll be learning how to convert kilojoules per mole to kilojoules per gram. This is a really important video because this is one of the most important skills that you need to learn for O-level type of questions. Okay, so let's try to think. What does kilojoules per mole even mean? That means when I burn, right, 1 mole of CH4, by the way, this is methane. So if I burn 1 mole, right, I will get this amount, 802 kilojoules of energy. If I burn 1 mole, I produce 802 kilojoules per energy. So now I want to count, right, if I burn 1 gram, what is the amount of energy formed? Okay, so let's think about it. Okay, let's think about it. I'll write the working here. If I burn 1 mole, right, of CH4, you can write this together with me. I would produce 802 kilojoules. So what happens if I burn 1 gram? What do I get? That is the question. So we must first find the ratio. How many grams is actually 1 mole of CH4? Okay, so therefore this is back into what we call molar mass. What molar mass means is molar mass is the mass of 1 mole. And molar mass is also equivalent to mR. I think some of you might hear mR a bit more often, some of you might hear molecular mass, but I think molar mass is quite good. So the molar mass of CH4 is that I take C, which the mR of CH4, if you cannot remember, please recall, it's 12 plus 4 times 1. Because 12 is the mass of carbon and 4 times 1 is the mass of hydrogen. So the molar mass is 16 CH4. What does this actually mean? Because some of you might not recall. It means that 1 mole of CH4 has a mass of 16 grams. You must remember this relationship very well. That's what molar mass means. 1 mole of CH4 is 16 grams. So linking back, so once I found this, linking back to my first equation, 1 mole of CH4 is 802 kilojoules, right? I know that 16 grams will produce 802 kilojoules. And if I know 16 grams will produce 802 kilojoules, 1 gram will produce 802 divided by 16 is 802 divided by 16. It will be 50.1 kilojoules per gram. Alright? Okay, so that is 50.1 kilojoules per gram. Alright, so let's look at the next one. The next one is called ethane. Ethene, okay? And let's go through the step one more time. So, first we find out what is the molar mass of ethene. So this is step 1. And we found out this is 2 times 12 plus 4 times 1. That is 28. And what does this 28 mean? This is step 2. It means that 1 mole of ethene is equals to 28 grams. Now, taking note over here, step number 3, I also know that 1 mole of ethene will produce 1437 kilojoules. Okay? And step 4, linking equation 2 and equation 3, I therefore know 28 grams of ethene will produce 1437 kilojoules, and therefore my last step, 1 gram is equal to 1437 divided by 28, and my calculator says that 1437 divided by 28 is 51.3 kilojoules per gram. Okay, right. Let's try doing hydrogen together. Now, the hydrogen, first problem that all students have, and you must not fall into this trap, is the formula for hydrogen. What is the formula for hydrogen? Okay, the formula for hydrogen is H2. You must remember that the formula of hydrogen is H2. Therefore, the MR of hydrogen is 2 times 1 equals to 2. So the molar mass of hydrogen is 2. That means that 1 mole of hydrogen is equals to 2 grams. Based on our data up over here, we know that 1 mole of hydrogen will produce 286 kilojoules. Right? And that means that 2 grams of hydrogen produce 286 kilojoules. Now, that means that 1 gram of hydrogen produced 286 divided by 2 equals to 143 kilojoules of energy per gram. So over here, I write 143 kilojoules per gram. Okay, and that's how you convert per mole to per gram. And we must remember this. But what does this even mean? So why is this important? It's because if we want to decide what fuel to use, we want a fuel that is both environmentally friendly and we want a fuel that produces a lot of energy. But when we see the energy production, we must be thinking, should I look at per mole or per gram? Now, we must understand that in the industry, in the real world, we wouldn't say that, oh, I want to buy 1 mole of hydrogen. We wouldn't use units like 1 mole in the real world. In the real world, what we are concerned more is the mass. If I buy 1 gram of hydrogen, right, how much energy can I produce? So in the real world context, when I'm considering whether the fuel is efficient, producing a lot of energy, we will use the kilojoules per gram unit to make the comparison because we are more interested in the mass when we are creating these type of things. Right? So I hope this lesson has been okay for you, and it's a very important concept here. So I hope that you would go through this and make sure that you understand it well. Okay? All the best.